This video is going to be a short introduction to stoichiometry. It goes along with the notes and practice that are on the website. In this unit, you're going to need your calculator a lot. It's very math intensive. So basically, we're going to use our dimensional analysis that we did in our mole unit to determine masses and volumes of reactants and products. This slide just shows a generic type of word problem that we're going to have in stoichiometry. So it's just asking us if we have a certain amount of reactant and enough of the other reactant, in this case B, how much product will we form? Okay, this slide is pretty self-explanatory, so I'll just give you a couple of seconds to read through this on your own and fill in the notes if you are following along with that. To perform our stoichiometric calculations, we are going to need to know our mole-to-mole ratios, and this is just a conversion factor of how many moles of each reactant and each product and the products there are. To get the molar ratios of any chemical equation, we need to make sure that it's balanced and that the correct coefficients are in front of the reactant or product. Here we're going to practice writing mole ratios, and we're going to use this balanced chemical equation here. Magnesium plus nitrogen yields magnesium nitride, and these are actually supposed to be subscripts. Did not convert over well. So our mole ratios are just going to be conversion factors where we basically are writing them like fractions. And here a good place to start is to just look at your first reactant that you have on the left side, and here it's Mg, and we have to look at the coefficient in front of that reactant. So here we have 3 moles of Mg. That's what the 3 is for. So we have 3 moles of Mg, and for every 3 moles of magnesium that's reacting, we have, nothing's written here, so we assume that's a 1 mole of N2. So our mole-to-mole ratio of magnesium to nitrogen is 3 moles of magnesium to 1 mole of nitrogen. And we know in dimensional analysis, whatever we have to cancel out, we want to put that on the bottom or opposite of what we're trying to cancel. So it can be written as 3 moles of magnesium over 1 mole of nitrogen, or we see the reciprocal here. It's not lined up correctly, but we can see what it is. 1 mole of nitrogen over 3 moles of magnesium. And we can write ratios for anything that we have present in our reaction. So we see the ratio here of magnesium to magnesium nitride. So for every 3 moles of magnesium that are reacting, 1 mole of magnesium nitride is produced. And then we have here our mole ratio of nitrogen to magnesium nitride. So for every 1 mole of nitrogen that's reacting, we have 1 mole of magnesium nitride that's produced. So here's another example of just writing some mole ratios. Remember, the most important thing here is that our reactions have to be balanced, so we have to have the correct coefficients here in front of our reactants and products. So a good place to start is just with your very first reactant. So here we have 3 moles of calcium. So I'll write that, and I am going to write the mole ratio for calcium to, we'll say, hydrogen gas over here. So for every 3 moles of calcium that reacts, there are 3 moles of hydrogen produced. And remember that in conversion factors, we can write it either way. So this would be the same mole ratio. For every 3 moles of hydrogen that's produced, we have 3 moles of calcium reacting. So to save time, I'm not going to write out all of the mole ratios. This is on the PowerPoint version of this. All the answers are written out, but you can do the mole ratio for calcium, to calcium phosphate or calcium to phosphoric acid. Keep doing that. The first type of stoichiometry problem that we're going to do is to go from moles of one substance to moles of another substance. So what we're going to do is first write the balance equation, and then we're going to use our dimensional analysis to multiply by the correct mole ratio. Here's an example of a mole-to-mole conversion, and it asks how many moles of calcium chloride will be produced if I start with 5 moles of hydrochloric acid, or HCl. So what I need to do is look at what is involved in this reaction, or this problem, and I have to find my mole ratios like we did on the other side. So here I'm going to have, for every 2 moles of HCl that react, I produce 1 mole of CaCl2. Remember that we can write it 2 ways, so I can also put 1 mole of CaCl2 on top and have my 2 moles of HCl on the bottom. So to figure out which one I'm going to use, I'm going to go ahead and set up my dimensional analysis by putting a question mark, and what am I looking for? I'm looking for calcium chloride, or CaCl2, and I'm going to set that equal to what I'm given, which is 5 moles of HCl. So when I'm doing dimensional analysis, if I want to cancel out this 5 moles of HCl, or the moles of HCl, the unit, then I'm going to have to put that at the bottom of my next conversion factor. So then I know that I have to use this mole ratio here, so that I have my 2 moles of HCl on the bottom and 1 mole of CaCl2 on the top. Then my moles of HCl cancel, and I'm left with the unit that I want. Once I get the unit I want, I can go ahead and do my math. So that's 5 times 1 on the top, and then just 2 on the bottom. So my final answer would be 2.5 moles of CaCl2. And this information is also on the PowerPoint version of this video. And that is all for now.